Hello tech enthusiasts! Have you ever wondered if a virtual machine can match the performance of a physical machine? Stay until the end to see all the tests we ran on a virtual and physical machine using the exact same Linux distribution. The host is Arch Linux. I have GNOME Boxes installed, so we open it and create a virtual machine using the file download. GNOME Boxes uses libvirt to manage virtual machines, QEMU to emulate the hardware, and KVM to speed up the main processor. When downloading, we set the name, amount of memory and disk space. I will use half the memory and the default disk space. We run the virtual machine, and it starts Arch Linux just as it would on a physical machine being virtual. We skip network setup. We run Arch install in localhost. We select the region, for example the United States, and we enable the multi-lib repository. In the disk configuration, we select partitioning. We let Arch configure the disk correctly, and then we choose the ext4 format. We leave the following options as default. Then we go to authentication, set the root password, and then we confirm it again. In user accounts, we select add a user. We enter user and password. We say it is a super user, and then we confirm the data. Then, in profile, we select the type, then desktop, and for this test, I will use KDE Plasma, which is the host desktop. In applications, we select audio configuration, then pipewire, and we leave all the other options as they are by default. In the network settings, I will leave the ISO copy option, although on a physical machine I would enable the network manager. We enter the extra packages. We press the / and we write the package name. I will add Firefox and then we exit now. Then we go down to the install option and select yes to continue. The installation process will start immediately right now. Arch Linux is a rolling release distribution. For many, it is the biggest advantage, but for others, it can cause problems. It finished in about 3 minutes, then we select reboot. The system starts for the first time, and we open a host terminal. We also open the terminal in the guest, but as Plasma Meta was chosen, it only installed the basics, so we must install it. Opening the terminal, we run fastfetch on the host. Then we install the packages we will use on the guest, like Sysbench. We run fastfetch. We can see that we use the same kernel. Now memory and disk change as the host runs everything else too. Using a command we verify info, the distribution, the kernel, and the memory. Remember, the host is running OBS Studio software. Also the disk and boot time, 16 seconds on the host and 4 seconds on the guest. The host has many extra services. Now we run Sysbench to evaluate the system. We test the processor with one thread to see events per second it can execute. We also run it on the guest. The difference is minimal, indicating that the overhead was low, being similar to the host. Then we evaluate the processor with 10 threads to see its behavior and concurrency management while stressing the load now. We run it on the guest and the result favored it by a few events, which is normal, because the host runs more processes. Now we evaluate threads to see how concurrency is managed at the worker level in the system and how it is handled overall. We ran the same command on the guest, and the result was lower by 800 events per second. The host handled it better. Then we test mutexes with Sysbench, this to evaluate efficiency and log management when loading the system scheduler now. We also do the tests on the guest, and the host executed the evaluated events in less time, managing them in a better way. We test memory read speed with Sysbench to evaluate the management of it when obtaining data from the system memory now. We run on the guest. Unlike the processor with KVM, memory has no native access, passes through a layer, and is slower. Now we test memory writing to evaluate the speed at which data is written to it and its management by the system software. Running on the guest, we see a much lower result, like reading memory writing. Also has a higher overhead in this machine. Then we prepare the files needed to test input and output, measuring the sequential writing speed at the same time as well. We run on the guest, but again the virtual machine shows overhead, due to an additional access layer in communications. We run Sysbench, but indicating it is to evaluate random file I/O, that is the input and output of the hard disk randomly. Running the same command on the guest, it is faster. This due to Virtio and being a smaller and less fragmented disk volume. Now we run the top command. We run Firefox to analyze memory consumption per browser tab. We open a video in the browser. Then we open a third and fourth tab to see the average memory consumed per tab. The average result was 400 megas. Again, we run the top command and Firefox, but on the guest, always analyzing memory consumption per tab, we open a video. Then a third and fourth tab. Memory consumption per tab was similar to the host. In this case, we have a total tie here. We run GL Mark II and it uses the default card to render, which is Intel shading measures pixel and shader calculations now. Effect 2D evaluates accelerated 2D rendering. Desktop simulates a real desktop environment. The host score is very high here. We run GL Mark II on the guest. Texture evaluates load and texture access with the jellyfish test. It renders transparency. Shadow evaluates shadow projection. Conditionals evaluates shader conditions. But many of the tests failed during this run. This is because it uses a virtual GPU focused on the desktop, not high performance. That is why performance was very low. Now we use the full screen option to see the guest on the whole screen. Response time is excellent. We change resolution. This way we verify that the virtual GPU is optimized for desktop use, not for 3D rendering with OpenGL technologies today. We exit full screen, shut down the VM, and close GNOME Boxes to go to the video conclusions regarding all the tests done. In conclusion, KVM offers performance very close to native, with slight loss in memory and disk, but enough for daily use. The virtual GPU limits 3D performance, but Boxes provides a fast and stable desktop experience for most of the tasks. That has been all for this video. If you liked it, subscribe, leave a like and turn on notifications. See you in the next video.